Hello class, today we're going to be covering lesson number 5 in chapter 6 and we'll be discussing slope. Slope generally is, we're thinking of slope as we're thinking of the steepness or the incline and as it relates to our graphs. So the more steep or the steeper, if we could say, a line is, obviously we're going to see it either going directly up or maybe directly down. Not necessarily straight down, but and the gentler the slope, the more it actually goes horizontal. So let's just take a look here and let's start reading on page 265. There's no doubt about it. Any creatures that can walk up a slope as steep as the one in this cartoon deserves to be called sure-footed. Now, if we take a look, we can see where this donkey is going up. It's almost like it's going vertical, even almost upside down to some of these angles here. It's just really now we know animals, for the most part, aren't able to do it. We've seen things like spiders crawl up a wall, and certain insects, and depending upon what kind of feet or webbing they have, or whatever substance that allows them to sort of defy gravity. But when we're talking about slope, we know that we are all challenged towards the steep slope, and we're going to now explain this in mathematical form so that we can better understand how to calculate slope. And we're going to start here. The left-hand diagram at the bottom of this page shows some donkeys walking up and down differing slopes. So let's take a look at these donkeys. And you could see that there's an A and a B and a C in the first illustration. And we can see here where the A, it has a more gentler slope than the B, but when we get to C, it's a very, very steep slope. It says the hill represented by line A is the gentlest, and the one represented by C is the steepest. In all three cases, as we look at the diagram from left to right, the lines represent the hills going up. These have positive slopes, so they're going upward. Now, if we look at the second diagram, it shows donkeys walking down hills in differing slopes. And in each case, we're looking at the diagram from left to right, that the lines representing the hills go down, and these have negative slopes. Now, it's very important that we say left to right, because if we were going the other direction from right to left, then it would be the opposite. But so these are negative slopes. So positive slopes are going upward from left to right, and negative slopes are going downward from left to right. Turning over to the page, now we have two others. We have a horizontal and a vertical line. It says here, if a line is horizontal, it goes neither up nor down, and its slope, being neither positive nor negative, is 0. So if you were just thinking, what's between the positive and negative group of numbers? Well, 0 is right in the middle. So that would have a 0 slope. Now, if a line is vertical, on the other hand, we often say that it goes up and down because there is no number that is both positive and negative. The slope of a vertical line is said to be undefined because you can actually be going either up or down as you're looking at this from left to right. You can see the donkey that's kind of pointing upward, and then if you're going downward, and again, it could go either way. So we could declare this undefined. The slope of all lines that are not vertical are given by definite numbers. To find a line slope, the following method is generally used. First, 2 points on a line are chosen. As we go from the left point to the right point, the direction in which we read, always left to right, we move a certain distance vertically, called the rise, and a certain distance to the right, called the run. The slope of a line is found by dividing the rise over the run. So let's see, we have a simple equation here. Slope is equal to rise divided by run, or rise over run. And I've always taught my class that it's very simple to remember what goes where, because you have to rise before you run. You cannot, if you're sitting down or if you're laying down, you could certainly not run. So you have to rise first and then run. So that is our slope, and we will actually get numbers that we can put into these formula so that we're able to determine what the actual number is for the slope. So let's turn over to the example on page 267, and Also, actually, before we get there, um, let's take another look here. Um, we have we have point A and point B, and I'm going to draw that up here real quick. And I want to illustrate something here. And let's get my pen up here. And let's take that point A and point B. Let's just draw it up here as they have it. And we know that we're always going from left to right. That's really what's important. So if I were to draw a line, and I'm just going to draw a straight line from here to here. Okay, these are our 2 points. First off, we see from left to right that it's actually going up. Okay, so this is a positive slope. Now, if we were actually going from right to left, it would be going negative, wouldn't it? It would be going downward. But that's why we really, it's very important that we understand left to right. Now, notice that they illustrate here rise, run, and run, rise, right? They have almost like 2 totally different numbers, or let's say angles to look at. We go rise and then run. Okay, so we have rise and run. Now our tendency is to run and then rise. Now the reason we have that tendency to run and rise is because when we give our coordinates, let's say I gave you the coordinate 2, 3, right? You would go to our graph and you would say, well, I go run first 2 and then rise 3. Be very careful with this. We really want to be careful with this, because if we do rise, run, run, rise, the slope of this, let's say if the rise were 2, okay, and let's say the run were 2, okay. Actually, that's not a good example because we'll get the same answer either way. But let's do it 2 and 4, okay. All right, so those are our numbers. So if we were going to look at the slope here, we would say, excuse me, there's an E here, okay. We would say rise over run. Oh, my pen is not really cooperating. Let's go back. Now, we would say rise over run. Now that's the formula. We can't change that formula. Can't say run over rise. So we would put 2 as a rise and 4 as a run, which means that it's 2/4 or 1/2, or we would simply say 0.5. That would be our slope, would be 0.5, 1/2. Now, what if we would have gone run over rise? Well, if we would have gone run, if we say, well, I'm typically going here and then I go up, I would have had 4 over 2. And we know that 4 over 2 is now 2, so there's a big difference between 0.5 and 2. And again, if I were to illustrate 4 over 2, imagine the distance. If this is 4, now the 4, we would have to come all the way up to here for 4 and only go 2. So you could see that the angle would really be different. So this would be wrong. We want to make sure that we understand that we put the rise first and the run. So when we're looking at a diagram like this, and let me just pull away some of the noise here and just focus on our little illustration, we have a simple formula of rise over run, and though we can certainly see the run underneath and the rise over here, we can certainly do that. We just have to make sure that we plot it into the formula properly. So we have slope is equal to rise over run. So regardless of how we look at it, we say, well, I have the run. Well, we have to put the run on the bottom. And as we said, the run was 4. Make sure you put the run on the bottom. You can certainly go run first, but very good to try to do rise, run. Get into the habit, rise, run. So it's a little bit different than saying what a coordinate is and finding a coordinate. But nonetheless, it is the slope. And I also want to just mention, and we don't have it in this textbook, but more modern texts refer to slope as m. Okay, m is like an abbreviation for slope, and just wanted to mention that. In fact, there are other ways to calculate points, and we can do that, but rise run is a very simple way to approach this rather than the mathematical ways that others do, and you'll learn that more in Algebra 2. how those mathematical formulas work. And you will certainly see the M for slope. Okay, but let's stick to our text and let's go to the example on top of page 267. It says find the slope of the line through the points 2, 1, and 6, 4. So if I were here on my graph, I would just go 2, 1, make my point, and then I would have to go 6 and 4. So there's 5, 6, 1, 2, 3, 4. So that would be here. So here's my point, my 2 points, and I'm asked to determine what the slope is. Now I know I have to do rise over run. Okay, so I would count 1, 2, 3. 3 would be my rise. Okay, so rise would be equal to 3 because I have to go up 3 to just get to the same line, or the y coordinate. Let's just, or the y coordinate on our next point. So I would have to go up 3. Then I'd have to count over 1, 2, 3, 4. So my run is now 4. Okay, so if I were actually moving up, I would draw my little arrow and then come all the way across, little curve there. So how would I calculate my slope? Well, my slope is equal to rise, which is 3, over 4, which is the run. And if we put that in decimal form, which we should, it would be 0.75. Okay, so we should express our slope in decimal form if we're not told to express it in fractional form, but 0.75 would be the slope. Okay, now if we read on, it says, as noted earlier, a line that goes down as we read from left to right has a negative slope. In the next example, we see how a negative slope can be found. So first, by graphing this equation, we have 2x plus y is equal to 1. So we're told to find the slope of this line. So we need to graph the equation, and so we have to find points. Any 2 points on the line, we would graph it, and it would look like the one here. Now you've already done that exercise, and you would know how to find an x and a y value and just plot your line. So I'm not even going to draw it on ours, but we can just reference our book, and we can see here that they have several points. They have the A point, which is -4 and 9. They have a B point, which is -1 and 3. They have a C point, which is 1 and -1. And they have a D point, which is 3 and -5. And if you were to take the rise and run of each of these, you will see you can go from A to B, and you should have the same slope from C to D, simply because it's traveling exactly in a straight line, so the slope will always be the same no matter where you're at on this line. And as we can see, it's negative, it's going downward from left to right. So it says any 2 points on the line, I'm reading in the solution after graphing, any 2 points on the line can be used to find its slope. It is easiest, however, to choose points whose coordinates are integers. Okay, that's obviously, you want to make your work a lot easier. Let's use integers. Now you can certainly use fractions, but you'll just make your math a lot much more complex. Now, if we choose points A and B, for example, the rise, or in this case, what's rise? It's actually dropping. So it's really a negative rise. If we were to remember, we can always speak of vertical language as being up or down, but when we're talking about rise, is, well, what if it's going up? It's positive. It's going down, it's negative. So we can certainly show rise as a negative, and in this case, it's -6. It's going. It says here that the rise, the drop might be a better word for this line, is -6, okay? And the run is 3, okay? So let's take a look. And how do they get -6? Well, if we were at -4, +9, that means we're at the 9 on the y-axis. We would have to drop all the way down to 3, which is -6. Now you might say, well, that's just 6 movements, but it's 6 in a negative direction, and this is critical now, that you understand that you're going downward, and that's why the slope is going to be negative. Why? Because, well, the drop is -6, but when we look at the run, we see that the run is +3. It's still moving from left to right in a positive direction, so the run is 3. Now what happens when you divide negative 6 by 3? You get negative 2. That's why we have a negative slope. So if you were just to tell me what's the slope of a line and you told me it's negative 4, negative 10, negative 3.1, I will automatically picture in my mind that a line going downward, okay? And if you told me a positive, obviously conversely I would think of something going upward. So this is the mathematical reason why we can say it, because we're sticking to the principle of rise over run. Now if we go right back to our board here and we saw that this was positive and this is positive, so we know positive divided by positive is going to be a positive. But let's say our point went down 3, okay? So let's say we had a point, let's put it right here. Put the same, same distance, but see, the rise would have been in a negative direction. So this would have been negative 3, and in this case, we would have moved over still positive 4. So now, what do we have? Well, we have rise of negative 3 divided by positive 4, which means it would have been, negative 0.75. Okay, so the line that would run from here to here is negative, whereas the first one we did was positive. So that's really the difference, is that one of these numbers is going to be negative, and you can see that there's a drop. But you always have to keep in mind that you're going from left to right. Left to right is very important. If you don't go from left to right, then you can run into a big problem. Now, I can certainly say, he says, well, what if I did go from left to right? What if shouldn't it work? Well, it certainly will. I'll tell you, it will work. Let me show you why. Because if I went right to left, I can say, for instance, that this goes down. What? This is going to go negative 3, right? If I were going from this direction to the other, if I were taking this point and going to this point, I would go down negative 3. But I would also go in a negative direction to the left, which would be negative 4, which means I would be dividing negative 3 divided by negative 4, which is going to yield a positive number. So even if I did go from right to left, I'd have to make sure that I have my negatives in place. I'm going negative, but I don't recommend this, and it's certainly not necessarily the way we want to do this. At some point, you may actually have to, but it's not really the best way to understand rise over run at the beginning. In this case, again, we could have gone run. We could have gone. I'm sorry. Let's go from this point down here, and we would have gone negative 4, but we would have gone up positive 3 from this point up to this point, which means we would have had positive 3 divided by negative 4. Again, it would have yielded a negative 0.75. So in a certain sense, regardless of which way I'm going, as long as I'm taking the movements properly, meaning I'm moving negative then positive, in this case we said go negative positive, we're still going to yield the same slope. Now, I just threw that in there because, like I said, you will be taking a point and maybe going in a different direction. You want to go backwards from left to right. But if we just simply understand that rise over run, as we look at it here, and we typically go with the rise first and then the run, and we plug in those values into our formula, it will yield the slope. Okay, and we'll go over some set 2 exercises in our next video.